way to set up our problem, like you did for your problem of the day over here. Okay? Now we need to figure out how to find these variables that we've been using to set up our problem. Okay? If we take our answer over here and we want to get back to the original one fraction, what would we do? Make a common denominator? And what's our common denominator always going to be? Our initial denominator, right? Okay. If we have, all the same denominators, then the numerator equation has to be equal, right? Right? Well, one way to do that with just getting rid of the fractions altogether is multiplying both sides of the equation by the LCD. Okay? If we multiply both sides of our equation by this original denominator, it'll get rid of all the denominators, and then we'll be left with an equation to solve for A, B, C, etc. Okay? Now over here, like on these four that we broke apart for our decomposition, all right, the x is going to cancel, but the a is going to be multiplied by something. All right, the x squared will cancel, but then the b is still going to be multiplied by something because it doesn't have that entire LCD. Okay. Now, after we do that, we need to solve for constants. Most of the time, we will be able to pick values for x to plug in. The most convenient values to pick for x to plug in are those that will make a factor 0. If we can make a factor disappear, then it will make one of our constants disappear, and we will only be left with one constant. Okay, this will make more sense as we get into an example. Okay. And then after we actually solve for our constants, we need to write the decomposition. Okay, we need to go back and plug A, B, C, yada, 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 back into our original setup. Are you ready? Does this problem look familiar? Yesterday we set this one up. All right. Those of you who do your notes consecutively, what did the denominator factor to? Okay. So we have three factors. Where x plus 1 is a repeated linear factor, which means all of our numerators are going to be constant since our factors are all linear. Okay, so this is as far as we got yesterday. Now the new steps to go from here to actually find A, B, C, we're going to multiply by our LCD, which in this case is just whatever our original denominator is. So x times x plus 1, the quantity squared. So when we take x times x plus 1, the quantity squared, what cancels out? Down here, right? So we're left with 5x squared plus 20x plus 6. Now, when I multiply a over x times the LCD, the x is going to cancel. Do you agree? Yes. So a is going to be left multiplied to x plus 1 squared. When I multiply b over x plus 1, only one of the x plus 1 factors will cancel, and b will be left to be multiplied by x and x plus 1. Okay? And then our last fraction, the x plus 1, the quantity squared, will cancel, and c will be left with x. Alright? Now, what we are going to do is we're going to strategically pick x values to plug in. Alright? We have an equation, so we know that both sides have to be equal. Alright? So, the nice x values to pick are the ones that are going to make our factors 0. So what's a number that would make one of these factors 0? If I pick x equals -1, all right, that means x plus 1 would go to 0, correct? Which means, okay, well, we have 5 times -1 squared plus 20 times -1 plus 6, all right? X plus 1. If x is -1, this goes to 0, which means a times 0, that disappears. Okay? Here, b times -1 times 0, that disappears, and we're left with c times -1. Now we only have one variable in our equation. What is c?
-9.
Positive 9. Alright? What is another x value we can pick that will make a factor go to 0? 0. X is a factor, so we can plug 0 in. So we have 5 times 0 squared plus 20 times 0 plus 6 equals, this is going to be a times 1, b times x, x is 0, so that's going to go away. C times x, x is 0, that's going to disappear. And so a is 6. Alright. Well, we have a and c, now we need b. However, we don't have any other unique factors to make 0, do we? No. Ah, yes. We can plug a and c in, can't we? If we can plug a and c in and pick an x value, we will only be left with b. Do you agree? So what would be a nice x value to plug in? We've already plugged in 0. 1 is easy to plug in, isn't it? So when x is 1, we have 5 times 1 plus 20 times 1 plus 6. This becomes a times, well, we know what a is, don't we? A is 6 times 2 squared. Plus, we don't know b, but b is times 1 times 2. C is 9, so we have 9 times 1. So what is B? Isn't it -1?
I agree.
Okay. All right, so now that we have all of our variables figured out, we're going to go back and actually write the decomposition. All right, so we originally started with 5x squared plus 20x plus 6 over x times x plus 1, the quantity squared. This breaks up into a over x plus b over x plus 1. Since b is negative, I'm going to say minus 1 over x plus 1. This looks nicer. Okay. Plus c over x plus 1, the quantity squared. That's the answer. Pretty slick, right?
Is that so much not going to be the same problem from last time except for going all the way through and solving it?
No, I think they're different problems. Okay. Now, when you have linear factors for your denominator, this method goes very smooth. It's very, pretty easy to just plug in values and solve, right? Okay, we run into a little bit of trouble when we have a quadratic factor. So let's look at that situation. This is not one that we have set up before. Okay. What does our denominator factor to? And can x squared plus 4 be factored?
No.
If it was x squared minus 4, we could factor it, but x squared plus 4 cannot be factored. If we set that equal to 0, we get imaginary 0, right? All right? So we have only two factors. We have x, which is linear, and we have x squared plus 4, which is quadratic. So we need a linear upstairs. Yes?
Is the x in the bx plus c the same as the x in x squared plus 4?
Like, will they be the same number?
Yeah.
Like if you plug...
Like, they're the same x?
Yeah.
Yes.
They are, okay.
Yes.
Making sure.
Yes. All right. Okay. We're going to multiply by what?
The bottom.
X times x squared plus 4. Which cancels out the entire, everything cancels out on the left. So we have 3x squared plus 4x plus 4. The x's cancel here, and a is left to be multiplied by x squared plus 4. And then here our x squared plus 4's cancel, and so bx plus c, the entire quantity is to be left multiplied to x. Make sure those parentheses get in there when you have a linear numerator. Okay? Now, if we try to use the strategy we used in our last example, all right, we can set x equal to 0, and that would be fine. But what would we pick to make this go to 0? It'd be imaginary, and that's not okay. All right, so we're going to have to come up with a different strategy. Okay? I have a quadratic equation on the left, right? We have x squared. Over here, this is quadratic, isn't it? And they're set equal to each other. So what should be true about the coefficients of each variable on both sides? We have, they should be equal, right? So what I'm going to do is I'm going to multiply this out. So we have ax squared plus 4a plus bx squared plus cx. And I'm going to organize this so that it's in descending order. Okay. We have ax squared plus bx squared. So I'm going to write that as the quantity a plus b times x squared. Is that okay? All right. And then plus cx plus 4a. And we know that this equals 3x squared plus 4x plus 4. Okay. So what do we know about a plus b? What must it equal? A plus b must equal 3. C must equal 4, and 4a must equal 4, because those are our constants. So yes, A equals 1, which means B equals, and we have C equals 4. Okay. Now it's possible that these equations could get a little more complicated in this, where you might have to use your strategy of substitution from a solving system of equations like we did on our quiz the other day. All right, it just depends. But most of the time they're going to be pretty straightforward, okay? So now that we have A, B, and C, we can write our decomposition. We had A over X plus BX plus C over X squared plus 4. There's our decomposition. If I make a common denominator, multiply the first one by x squared over 4, x squared plus 4 over x squared plus 4, multiply the second one by x over x, we're going to get back to what we originally started with. Any questions on this strategy? I'm going to do 2 more. This one and another one. What does our denominator factor to? X plus 4, x plus 2. We have 2 linear factors for our denominators. So we have a over x plus 4 plus b over x plus 2. Remember, it doesn't matter if x plus 4, x plus 2 comes first for your denominators, because when we get to the end, all right, your constants should still be the same. All right? And we are going to multiply by and so what are we left with on the left? A will be multiplied to, okay, because the x plus 4s will cancel. And then B times x plus 4 because the x plus 2s cancel. All right. Now, what would be a good, this is all linear. All right. So we can pick zeros. What would be a 0?
-2.
We pick x is -2. What do we have on the left? +6. All right. A is going to disappear.
Yes.
And B is going to be multiplied to 2. So what's B?
3.
What is the other number we can pick? -4 will create a 0. And so x plus 8 gives us 4. A is going to be multiplied to -2. And B is going to disappear because x plus 4 is 0. And so A is. So our partial fraction decomposition is going to be A over x plus 4 plus B over x plus 2. This would be the same thing as if you wrote 3 over x plus 2 minus 2 over x plus 4. Okay, so when you're looking in the back of the book to check your answers, all right, just make sure you understand, you know, the commutative properties. These two are the same. Okay, feeling good? Feeling good. Let's do one more. And then you'll get a good amount of time to work on your homework in here, so you have each other and me to help you before you go into the weekend. All right? This is the hardest thing we're doing this chapter. This concept. Just sort of talk about this chapter. All right. Our denominator's already factored in.
Yay.
Yeah. All right. And what do we have in our denominator? A repeated quadratic. So I'm going to put ax plus b over x squared plus 2 and cx plus d over x squared plus 2, the quantity squared. So now we get to multiply by our LCD. And what do we have on the left? Okay. X squared plus 2 will only cancel out with one of these from the LCD. So ax plus b, the quantity, is going to be multiplied by x squared plus 2. All right. Make sure that gets in parentheses. All right. And then this denominator cancels out with the entire LCD, so we're just left with cx plus d. Since we had quadratic factors, our strategy of picking 0 is not going to work because the number to make this 0 is imaginary, and that's just not okay. So instead, we need to compare our coefficients. So let's multiply this out. We have ax cubed plus 2ax plus bx squared plus 2b plus cx plus d. And then we're going to compare, well, we need to group like terms together, right? So we only have ax cubed, and we only have bx squared, but we have a 2ax and a cx, so I'm going to group those together. And then our constant term is what? 2b plus d, right? Everyone okay with what I have up there? All right. So we have 8x cubed. So a equals 8. B is the coefficient of x squared. There is no x squared, which means b needs to be set equal to 0. 2a plus c needs to equal 13. And 2b plus d needs to equal 0. So a is 8, b is 0. If I plug a equals 8 into 2a plus c, that makes c equal to what? And if I plug b into 2b plus d equals 0, b is, okay. So our partial fraction decomposition is ax plus b, so 8x plus nothing over x squared plus 2, plus bx plus d, which is nothing. All right. Now, since this, we don't have a d here, it's just 0, and c was negative, I'm going to go ahead and write this as a subtraction. Right? If you write it as plus a negative 3x, that is not a problem. All right? But I just think this looks pretty. Any questions? I would like you to use your time wisely. You need to be working on this assignment. If you have any questions, we can work through those before you have the weekend, where you're on your own.